I'll be explaining about current setting in an overcurrent relay. Current setting is also called as pickup current setting. Is also called as pickup current setting. So simply it is called as current setting. So it is used for adjusting or changing the pickup value of a pickup current value of a relay, of an overcurrent relay. Okay. So by using this current setting, we can adjust or change the pickup current of a relay. So far we know that this overcurrent relay, let us suppose this is an overcurrent relay. Inside this relay there is a relay coil that is fed from the current transformer, and the relay has relay contacts that are connected to the trip circuit. Also, there are two settings for this overcurrent relay, one of which is time setting and the other one is current setting. So in this class we will focus on this current setting. So this is used for adjusting the pickup value or pickup current value of an overcurrent relay. So far we know that pickup current is the value of relay coil current above which the relay operates. In the sense, when the relay coil current, which is nothing but the secondary current of the current transformer. So this is the current that is flowing inside the relay coil, IR. So whenever I am talking about pickup current, it means that I am talking about the relay coil current. Okay, so it is that value of relay coil current above which the overcurrent relay, I can say this is an overcurrent relay, operates. So if the current IR just exceeds the pickup current, then the relay will operate. We also know that inside the relay there are two torques, operating torque and restraining torque. And for the relay to operate, operating torque should be greater than the restraining torque, because restraining torque opposes the relay operation. It means restraining torque doesn't allow the relay to close its contacts, whereas operating torque is that torque that is created by the relay coil, and it tends to close the relay contacts. So there is a tug of between the operating torque and restraining torque inside an overcurrent relay. Okay. So whether operating torque is greater than the restraining torque or less than the restraining torque is decided by the amount of current that is flowing inside the relay coil. If the relay coil current is less than pickup current, then the operating torque will be less than the restraining torque. In this condition, the relay doesn't operate. Relay restrains, we can say, or relay doesn't operate. If the relay coil current equals to pickup current, in this case the operating torque will be just equal to the restraining torque. It means that the relay has produced an equal torque in opposite way to the restraining torque. In this case, the relay is at the verge of its operation. It means it is ready to operate. But if relay coil current is greater than the pickup current, then the operating torque exceeds the restraining torque produced by the spring, and the relay will operate. Relay operates. If relay operates, the contacts are closed and the trip circuit get energized, and the circuit breaker isolates the fault. So here IR is the deciding term. Here I pickup is the deciding term, because relay cannot see the fault. It doesn't have sensory organs. It only decides whether the current flowing in it is a fault current or a normal current, depending upon its pickup value. If the current is less than pickup, it will consider it as a normal current and it will restrain its operation. It will not operate. If the current is greater than the pickup value, then the relay will treat it as a fault current. So whether to treat a particular current as a fault current or a normal operating current is decided by the pickup current of the relay. So it is very important to know how to adjust the pickup current. Second one, how to adjust or how to change the pickup current. Second one, why to adjust. Third one, how to select a proper pickup current. How to select a proper pickup value so that the system remains protected for all operating conditions. Okay. So let us start with how to adjust the pickup current, and later we will talk about. I will talk about why the adjustment is necessary. Why a relay should have this feature of pickup current adjustment or current setting. Why a relay should have the current setting feature. And at the end of the video, I will talk about how to select a proper pickup value for an overcurrent relay. See, the two torques that are present in the relay, first the restraining torque and the operating torque, right? So this restraining torque is produced by a spring. In an electromagnetic overcurrent relay, the restraining torque is produced by a spring, and this torque TR is independent of relay coil current IR. So IR doesn't have any bearing upon the restraining torque or the torque that is produced by the spring. This torque is opposing the relay's operation, right? So this torque is almost fixed because it is not depending upon IR. IR value is changing, but this torque is fixed. But this torque, T operating torque, is produced by the relay coil. It's produced by the relay coil. Okay, so relay coil is having certain number of turns, okay, and certain amount of current, some definite amount of current, finite amount of current is flowing inside the relay coil. So there is an MMF established by this relay coil, so that is used to produce the operating torque. Operating torque in electromagnetic relays can be produced by either by electromagnetic attraction or by electromagnetic induction. In both the cases, the operating torque depends upon the flux produced by the relay coil. Phi r is the flux produced by the relay coil, and the flux produced by the relay coil depends upon the MMF produced by the relay coil. Okay, that is nothing but the ampere turns of the relay coil. So N is the number of turns, IR is the relay coil current. Okay, so let me take an example here. So we have this relay coil. Okay, let us suppose it is having N1 number of turns. Okay, and it is having the current flowing is I1. I1 is the amount of current that is flowing in the relay coil, and under this condition, the MMF produced is MMF. Let us suppose I am calling it as MMF1. MMF1 equal to I1 N1. Okay, and here this MMF is sufficient enough. Let us suppose, I am just taking an example. Let us suppose this MMF1 is sufficient enough to produce an operating torque. So this MMF is producing an operating torque. Okay, this MMF is producing an operating torque, and that operating torque is sufficient to overcome the restraining torque. And that operating torque is sufficient to overcome the restraining torque. So if the MMF produced by the relay coil is creating a torque, and that torque is just equal to the relay coil, that torque is equal to the restraining torque. In that case, the current flowing in the relay coil, should be equal to the pickup current, right? So I1 should be equal to pickup current. See, previously I have discussed this. Okay, when the relay coil current equals to pickup current, then the operating torque will just be equal to the restraining torque. It means that if the current is now slightly greater here, if the relay coil current is greater than pickup current, the operating torque will exceed the restraining torque. Okay, let us suppose a particular value of MMF. In this case, the MMF established by the coil is producing an operating torque by this coil. So the operating torque is produced by attraction or induction. Okay, so the operating torque is equal to the restraining torque. In other words, this current is nothing equal to the pickup current. This current is nothing but the pickup current. Now I am taking a different case now. Let us suppose the relay coil turns are reduced to N2. Okay, N2. So such here N2 is less than N1. But I want to produce the same torque MMF1. Okay, so MMF1, let me define here. So relay coil MMF at which T operating torque will be equal to restraining torque. So this is that MMF. I want to produce the same MMF now, but with N2 number of turns such that N2 is less than N1. So we have N2 whose value is less than N1. So now in this case, let us suppose the current drawn by the relay to produce the same MMF is I2. Okay. So we have reduced the turns, but to produce the same MMF, here this I2 should be greater than I1, right? Because this term is fixed here. I want to produce the same MMF. Okay. Here I2 will be increased. In other words, to make the operating torque equal to restraining torque with reduced number of turns, relay will draw more current. Okay. Or we can say that the pickup current of the relay has increased. So here I2 will be equal to I pickup, right? Because at this MMF1, operating torque equals to restraining torque. Okay, so this is not changing. This is fixed here and here. We have reduced the number of turns, and to produce the same MMF or to produce the same torque, relay is tolerating more current, is accepting more current to produce the same torque. If I take one more case, to produce the same MMF, let us suppose the number of turns are N3 and N3 is greater than N1. N3 is greater than N1. So here we want to produce the same MMF. We have increased the number of turns. We have increased these turns. So what will happen to the current? Current will decrease. Okay, because we are producing the same MMF. So here I3 equal to I pickup. So if you observe these three conditions, I1, I2, I3, here pickup value is equal to I1. Okay, and here pickup value is I2 and pickup value is I3. Okay, so here I1, okay, I2 is greater than I1. Okay, I2 is greater than I1. All the three are pickup currents. Okay, these three are but three different values. How we obtain three different values? By changing the number of turns of the relay coil. Here the number of turns are N1. Here the number of turns are N2. Here the number of turns are N3. Okay, I2 is greater because we have reduced N2. Relay is taking more current. And I3 is less than I1. I3 is less than I1 because N1 and N3 is greater than N1. So we increase the turns. So relay will take less current to produce the same torque. From this we can understand that we can obtain different values of pickup current by changing the number of turns of the relay coil, by adjusting the by adjusting the number of turns of the relay coil. So from this we can understand that pickup current can be adjusted by changing the number of turns of relay coil. Okay. So we have this relay coil and it will have some tappings. So this relay coil is fed from current transformer. So this is from CT secondary. Okay, so we have a tappings and we can change the number of turns of the relay coil, based on which we will get different values of pickup. Of course, for one particular application, we fix the pickup by fixing the number of turns. So we may select this position or this position or this position, and for one particular application we will fix the number of turns and the pickup is fixed for one particular application. But if you want to change it, we can change the tappings provided inside a relay, and we can change the pickup current. In fact, in an electromagnetic overcurrent relay, we have something called plug setting bridge. We have something called plug setting bridge. Okay, so this tapping can be selected here, 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 or here. Okay, there is a certain adjustment there, certain arrangement provided in an electromagnetic relay, and this arrangement is called as plug setting bridge. Okay, so the user will be given a plug, and the user can place the plug here, here, or here, or anywhere among these tappings. So based upon the plug location, particular tapping level will be selected. So it is called as plug setting bridge. This plug setting bridge will help for the current setting. Okay, current setting of the relay. So there is a now let me define the pickup current formula. So pickup current equal to CT secondary current multiplied by current setting of relay, multiplied by current setting of relay. So this is given on the CT rating, CT secondary current, and current setting of the relay depends upon the plug position. Okay, so we can get the current setting value from the position selected. Let us suppose this position may have a current setting of 50%, this position may have some 25%, okay, this position may have some 10%, this position may have some 100%, something like that. Okay, or we may have something like 110%. Okay, so we have different current settings available on the plug setting bridge. Essentially, by selecting any current setting, essentially we are changing the number of turns of the relay coil, and by changing the number of turns of the relay coil, we are changing the pickup current of the relay coil. So this current setting is usually expressed in the form of percentage. Okay, 20%, 50%, and so on, 100%, something like this, 125%, etc. Okay, let us suppose the CT, we have a CT of 100 by 1 ampere. So this may not be a practical CT, but I'm taking an example for easy calculation. And we have a relay whose current setting is 0.5, whose current setting is 50%. Okay, then pickup current, I pickup equal to CT secondary current multiplied by current setting, right? Current setting. So that equal to CT secondary current is 1 ampere multiplied by the current setting, that is 50 by 100. So that is 0.5 amperes. Okay, so this is the selected current setting value. We may increase it or we may decrease it based upon our need, but we don't change it often. Only whenever it is necessary, we change the current setting to get a desired pickup level. So this is the first aspect. Okay, how to adjust the pickup current of the relay. So pickup current of the relay can be adjusted by selecting an appropriate plug location in the plug setting bridge. So this is external to the relay. Externally, we can select a particular current setting value. Internally, in the relay, we are changing the number of turns of the relay coil. Second thing is why to change or why to have a relay with different current settings. Why to establish, why to have this kind of current setting feature inside a relay? Why to have this kind of current setting feature? Let me take a power system load. Okay, these are group of houses or an industry. Okay, let us suppose the maximum load current here is 200 amperes. This is the maximum possible load current. Okay. So I want to predict this load. So we are placing an overcurrent relay here. Of course, there will be circuit breaker also associated with this relay. Okay. So we can adjust the pickup of this relay. So maximum possible overload load is 200 amperes. So let me take a little bit more, a little tolerance value. Okay, and I will adjust this pickup to 2.2 amperes. Just just to accept some overcurrent. So if it is a 100 by 1 ampere CT, 100 by 1 ampere CT. So we have a 100 by 1 ampere. So if 100 amperes is flowing here, 1 ampere will flow in the relay coil. So the maximum current is 200. So this relay should allow the maximum possible current without tripping. It should not close the relay contacts when maximum load current is flowing. So maximum load current is 200. So if 200 is flowing here, 2 amperes will flow here. In that case, the relay should not operate. But if greater than 2 amperes is flowing, then there might be some fault here. So the pickup I have adjusted it to 2.2 amperes. Let us take an example. Now, after some time, we have the number of households in this locality have increased, or if it is an industry, the load in the industry has increased and it has reached 400 amperes. Let us assume just all of a sudden. Okay. So a new township has been established in our neighborhood, and all of a sudden the load has doubled. It might not be practical, but I'm just taking an example. So now we have a relay with whose pickup is 2.2 amperes. So we have to replace this relay. If there is no current setting feature in this relay, we have to replace this relay and purchase a new relay whose pickup may be close to. So the CT is 100 by 1 ampere. If I'm taking 100 by 1 ampere CT, whose pickup is close to 4 amperes, right? Let us suppose 4.2 amperes or 4.4 amperes, right? To tolerating some amount of overload. Okay, we have to purchase a new relay. But if this relay itself is having a future of a current setting or future to adjust the pickup, we will adjust this pickup to 4.4 amperes. So that is the reason why we require a current setting or pickup current setting adjustment future in a overcurrent relay. And also this helps the if there is such future where we can have a same relay with a different pickup settings, it will be easy for a manufacturer to manufacture same model relays for different applications, right? For different load levels. Okay, because of those reasons, we desire to have a future of current adjustment. Also, let us suppose we want to use the same relay. Okay, now we have closed this township and we are not using this load, and I want to use this relay somewhere else. Here the load current, maximum possible load current may be 1000 amperes. So there is one more load here, industrial or domestic load, and here the maximum load current itself is 1000 amperes. So then this relay, let us suppose the pickup will be adjusted to 10.5 amperes. Okay, so taking a 100 by 1 ampere CT, 10.5 amperes. If there is no feature to adjust the pickup current, I cannot use this same relay here. I have to purchase a new relay. So same model relay can be used at multiple places for different load levels if there is a future of current setting. So second aspect to understand about current setting is why current setting is necessary. First one, we already understood how to adjust the current setting. The last thing is how to select a proper pickup value for a relay, for an overcurrent relay. Let me take a section of power system. So this is a section of load being fed by a feeder, and we intend to protect this load by using an overcurrent relay. So this is an overcurrent relay we are having here. Of course, there will be circuit breaker. I am not showing it for simplicity. Now we need to select, or we need to decide the pickup current of this relay. The pickup current should be such that the relay can sense the least severe fault. So first, let us suppose on this load, if there is a fault anywhere in the system, it is drawing 1000 amperes, and if there is one more fault and another fault, it is drawing 200 amperes. One more fault is there somewhere. All these faults are occurring at different point of times. I am showing them together. Let us suppose one more fault, it is drawing only 100 amperes. Okay, so any fault, any other fault is drawing anywhere between 1000 and 100 only. So 100 will be the least severe fault on the system, least severe fault. So the relay should pick up even for the lowest magnitude of fault current. So that is one criteria to select the pickup. If the pickup is very high, in the sense if the pickup is value is more, then the relay may not consider the lowest magnitude of fault current as a fault current, as a faulty situation. It will think it as an overload situation. So we should, while framing or while setting the pickup, we should consider that the relay can sense the least severe fault. Second thing is, let me erase this whole thing. Second aspect is, the pickup should be such a way that when this section of the power system is loaded to its maximum load, to its maximum full load. Let us suppose the maximum load current in this system is 50 amperes. In system is 50 amperes, and this is a 100 by 1 ampere CT. 1 ampere CT. So when this load is drawing its full load capacity, then the relay should not consider this as a fault current. So this load may not be drawing always 50 amperes. Sometimes it may be drawing 10 amperes, okay, 25 amperes, etc. But if it is fully loaded, then it is drawing 50 amperes. So this increment in current to 50 amperes, or when it is lightly loaded, it is 10 amperes only, and when it is fully loaded, it is 50 amperes. So relay should not consider this 50 amperes as a fault current, because it is a normal full load current, right? So the pickup should be such that the relay should tolerate the full load current. So relay should not operate under maximum loading condition. Maximum loading condition. So these are the two considerations. First thing is that it should operate even if the fault magnitude is very small. Second aspect is that the relay should not operate when the system is fully loaded. Considering these two, we decide we select the pickup current of an overcurrent relay. Let me take this example. So if 50 amperes is flowing, here 0.5 amperes will flow, right? 0.5 amperes will flow. If the relay pickup is, let us suppose if it is 0.7 amperes. Sorry, if the relay pickup is 0.4 amperes, the relay pickup is 0.4 amperes, then this full load current will be treated as fault current, because the current seen by relay 0.5 amperes is greater than its pickup. So relay will consider this current, this 0.5 amperes, as fault current. But if the pickup is 0.7 amperes, 0.7 amperes, if the pickup is 0.7 amperes, in this case, the relay will not treat this maximum full load current as fault current, right? So always the pickup current should be greater than the maximum full load current, where Imax is the maximum full load current. So here Imax is the reflected value of current seen by the relay. I'm not talking in terms of the system current. Okay. So the pickup should be such that maximum full load current will be tolerated. Sometimes we may go for some overloading also. So sometimes the load may go beyond the maximum full load also, and it may happen for very short duration of time, and it is tolerable for some time. Okay. So sometimes we may put a factor of overload tolerance called K. Okay, so K is the overload factor. Overload factor. Even if the current is slightly greater than the maximum full load current, the relay should be able to tolerate. So in some systems it is necessary. So we introduce this factor K, and K value is 2 for distribution networks. And K value is somewhere between 1.25 to 5 for generators and transformers. Okay, and K value is 1.05 for a motor. Okay. So momentary overloading should be tolerated. So we usually put pickup greater than or equal to K times I maximum. So that is one aspect. The second aspect is related to the fault current. Let us see this. Okay. So we have this power system, same power system. So this is the relay CT. So this is 100 by 1 ampere CT. Let us suppose the power system is experiencing a fault which has the lowest magnitude, that is 100 amperes current. Okay. So this current is IF minimum. Okay. Fault current due to least severe fault. This relay should operate even the fault current is very low in magnitude. So if 100 amperes is flowing here, 1 ampere will flow here, right? 1 ampere will flow here. If the relay pickup is set to 2 amperes, then this 1 ampere will be considered as a normal current by this relay, because relay after all doesn't know whether there is fault or not. It will only compare the current that is flowing into the relay to the pickup, right? So if the pickup is 2 amperes, this current will be treated as a normal current, although it is a fault current. Although it will damage the system, but the relay will sit silent because its pickup is set to 2 amperes. But if the pickup is 0.8 amperes, then the relay will treat this 1 ampere current as fault current. With this, we can understand that the pickup current should be less than the current caused due to the minimum fault current. This is the second condition. The first condition is that pickup current should be greater than the maximum current or the full load current. So with these two conditions, before going there, let us see if the fault is drawing 1000 amperes and this is the maximum possible fault current. In this case, how much 1000 amperes is flowing here? Here 10 amperes will flow. Here 10 amperes will flow. If 10 amperes is flowing, we have set the pickup to considering the lowest or the least severe fault. So that is 0.8 amperes. So if maximum current due to a fault, that is 10 amperes, is flowing and pickup is 0.8 amperes, this relay will obviously operate. So this relay will obviously operate. So we will only consider the least severe fault while deciding the pickup, because if we design the pickup by considering the least severe fault, the relay will operate for any other fault or the maximum severe fault. Okay, so we did not worry for other fault currents because we are setting the relay to operate even for the lowest possible fault current. So combining these two, we can say that I pickup should be less than IF minimum and I pickup should be greater than or equal to K times I maximum. So this is the condition to decide the pickup current of an overcurrent relay. Please subscribe to EasyBTech channel. I hope you understood why to adjust the pickup current, how to adjust the pickup current, and how to select an appropriate value of pickup current. Thank you.